Okay, good evening, ladies and gentlemen, and welcome to this day 2 of Lean Six Sigma Black Belt Certification Hackathon. Okay, so before we begin, let's quickly recap whatever we have seen yesterday. And if you remember yesterday, how many of you had taken the just a second. Yeah, how many of you have taken the this one notes? Now you can see that. Yes, the notes have been taken. So can we just quickly have a recap whatever we have covered yesterday? So if you remember, we started with CLT. If you remember, CLT is central limit theorem, correct? So we created first 5 data points, then 50, and then 50,000 data points, and then we have seen that lesser number of data points did not have normality, but as it goes beyond 30 data points, it slowly starts gathering the normal distribution curve. Why normality is important? Because our entire statistics model, the probability model, is depending on the normality shape of that. Okay, and today we are going to discuss even further more on that, right? So we discussed with CLT. Just give me a quick yes confirmation in the chat box, okay, if you remember that. So CLT we covered. Then after CLT, what else we have covered yesterday? Type in the chat box. Then we have seen what is measurement system analysis. Remember that measurement system analysis. So yesterday we have seen gauge R&R and AAA. So in the green belt level, we cover the basics of that. What is gauge R&R? What is repeatability? What is reproducibility? What is attribute agreement analysis? When it is continuous data, it is gauge R&R. When it is discrete data, it is AAA, right? And in the black belt level, we see the practical stuff of that, right? How do we put the data in the Minitab software? How do we analyze it? What are the do's and don'ts in that? So that is something which we have seen. So in the gauge R&R we have seen, then we have seen the GRR score, which is percentage contribution, etc. It should be less than 10%, then it is acceptable, right? And again, the NDC as well. We have seen NDC should be 5 or more than 5, then it is acceptable. That is about GRR. When it comes to AAA, AAA is used when we have AAA is what? Attribute agreement analysis. When you have attribute data like discrete data, yes, no, pass, fail, go, no go, etc. Right? So instead of gauge R&R percentage score, we have kappa value there, kappa value, right? So if you have seen that, we feed the data and check the kappa value, and if the kappa value is between 1 to 0.9, it's a best system. Okay. If your kappa value is between 0.9 to 0.7, you can still acceptable. And below 0.7 you need improvement in the system. Okay, so you should not basically take the data directly before improvement. Okay, so make sure that it should at least go beyond 0.7. That's what the measurement system analysis was. Clear? Yeah, remember, just give me yes in the chat box. I'm just recovering some of the information and knowledge we shared yesterday. Then we have seen the normality test, right? Anderson-Darling normality test. Now in the Anderson-Darling normality test, we have seen that if the data is below 0.05, that is non-normal data. So we discussed, we have done the normality test earlier with the normal data. Then we have given a file which is non-normal file. Then we checked and it found to be a non-normal distribution, which is less than 0.05. Then what did we do after that? Type in the chat box. Once the data was non-normal, what was our next step? Chalo, type in the chat box, because recap is not for me, it is for you. Very good. It was transformation. Absolutely right. So we went for transformation and we did Box-Cox transformation. So we went to stat, we went to control charts. In the control chart, there was something called Box-Cox transformation. Then we checked Box-Cox transformation, we feed the data into that, and we got a value called lambda value. Okay, yesterday the lambda value was found to be 0, and when it is 0, then you have to do the log transformation, and then we saw the procedure to convert your original data into a log data, and we understood the basic theoretical part as well, and then we did practical on on the Minitab, right? And after that we found that the data is normal distributed, then we check the process capability, correct? That much we have covered yesterday. Just give me a quick yes in the chat box. Just give me a quick yes. Clear? Anything else did we cover which I have missed? Very good. Covered everything? Super. All right. Let's now. So today what we are going to do is, once the process capability is done, then we enter into analyze phase, basically. Okay, in analyze phase, which we call it as prime, and we use to identify the primary causes, right? Then we go for root causes, which is nothing but root cause analysis or YY analysis. Okay, yes. I think there is a little glitch in the internet. That's the reason for this, but now it is okay, right? Yeah, I also got a little signal about it, but now it must be okay, right? Sadharanji, just give me a confirmation. Okay, very good, very good. Now, once the root causes are identified, then we go for, validation. And validation is done through hypothesis testing, regression, and DOE, etc. Okay. So basic level of hypothesis and basic level of regression we already have covered in the green belt level, because this is a black belt certification session. So what is basically we are looking at is hypothesis testing. We will go for advanced hypothesis testing. We'll go for advanced regression today. Okay. And tomorrow we will cover the design of experimentation, DOE. All right. So that is what. So where does hypothesis testing comes? To validate the actual root causes which we have identified. And validation meaning nothing but you are basically confirming. Okay. You are basically confirming your root cause with the data. You are validating, you are proving that your root cause is absolutely right root cause. Clear? And that is why it is called as a hypothesis testing. Hypothesis is nothing but assumption, right? So we check our assumption. So let's do the basic hypothesis first. We'll start with a 2 sample t-test. I'm just sharing a file, data file with you guys. Just open this 2 sample t-test data file. We'll start with that. You know, this is also already covered in the green belt level, but let's start with the basics. Okay. Once you opened it, let me know in the chat box. The name of the file is 2 sample t-test. When do we use 2 sample t-test? When do you want to compare the averages of 2 samples? It may be because of, coming from 2 different processes. It may be because of, coming from 2 different vendors, etc. Okay. Once you open the file, please let me know. Yeah, open. Very good. All right. So here are the 2 processes here, or 2 samples here. One is male CCO. CCO stands for call center officers, and female CCOs, female call center officers. Now we want to check whether any statistically significant difference between these two basically samples. Okay. So how do we go for it? Go to stat. Go to basic statistics, 2 sample t-test. Everybody follow this path, please. Stat, basic statistics, 2 sample t-test. Click on that. In the drop down menu, select the second option, each sample in its own column. In sample 1, select male CCO, sample 2, select female CCO, and click on OK. Everybody got it? Just give me yes in the chat box. So here, what we are doing here is, we are checking the average male CCO M. So the null hypothesis says average male CCO is equal to average female CCO. Alternate hypothesis will say average male CCO is not equal to average female CCO. Right? And then we check the p-value. P-value is coming to 0.044. Clear? If you remember our rhyming, P low, null go. If the p-value is lower than 0.05, null go. That means we reject null hypothesis. Reject null. So in this case, it is slightly lower than 0.05. So we reject null hypothesis and we accept alternate hypothesis, which says the average of male CCO is not equal to average of female CCO. Yeah. So I'll just repeat it once again. Go to stat, basic statistics to sample t-test. Follow this path. Stat basic statistics to sample t-test. And here in the drop down menu, you have to select each sample in its own column. Just click on the drop down, select the second option, each sample in its own column. Okay. And in the sample 1, select male CCO, female, and sample 2 selects female CCO. And click on OK. That's it. And you will get this. Got it? So it says to sample t-test. So the mean is 11.63 for the male and the female mean is 12.80. So understand this. What is p-value? If I have to draw the p-value, it would be like this. So the male CCO, the data distribution is like this. This is the average x bar m, okay, which is nothing but, what is that? 11.60. You can see here 11.63, which is 11.63 average. Okay, and what is the female average is 12.80. So if I draw the distribution of the female, so this is x bar f, which is nothing but 12.80. And you know what is this overlapping area, guys? This overlapping area is nothing but p-value. Okay, now in this case it is 0.044. That means right now, imagine guys, this entire data distribution to distribution, the area is, let's say, 100%. Okay, this overlapping area in this case is 4.4% right now. Only very limited area of overlapping. That's why what statistics is suggesting, that there is a statistically significant difference between average of male and average of female. Are you understanding? Just give me yes in the chat box. How many of you have understood this? So I have just plotted two distributions. One is male data distribution and the female data distribution. The average of male is 11.6. The average of female is 12.8. Okay. And whether there is any statistical significant difference between these two data points. That is what we are basically checking. And p-value is nothing but the overlapping area. If overlapping area is more, imagine this. if the what you can say, if both the distributions are exactly matching with each other, p value would be 1. That means it's 100% overlap. Are you understanding? Just give me yes in the chat box. If they are 100% overlapping, that means average of male and average of female is exactly same. 100% overlap, p value is 1, which is 100%. Now let's take it a little ahead. Okay, let's make a small difference. Now there is a small difference between an overlapping area, let's say 50%. Okay, still statistics say 50% is a very significant area. So there is no statistical significant difference between these two averages. The moment the area becomes less than 5%, then it says this difference is statistically significant. Are you understanding this? Earlier it was 100%, then 50%, and now then it is less than 5%. The moment it becomes less than 5%, it says it is now the distance is statistically significant. Clear? This is the simplest explanation of the p-value you can ever get. Just give me yes in the chat box. Have you understood this? Can you just give me yes, no? Yeah. Fantabulous. Okay, so see what we are checking here is, let's try to understand this. What we are checking is they have taken the data of average call center employees, the male call center employees. Are they better in closing the call, or are female better in closing the call? That is what they want to check. Is gender playing any role here? So they collect the data of male and they collect the data of female. That is x bar m is for the male data, x bar f is for the female data. Now the null hypothesis says x bar m is equal to x bar f, which is statement of equality, right? Green belt level. I'm just repeating again. See, this is green belt stuff. This is not black belt. Okay. Alternate hypothesis, there is a statistical significant difference. Yes, everybody with me? Correct? Now we collect the data, put that data in the software, and software calculates the p-value. Correct? The p-value you can see here, p-value has been calculated here. 0.044 or 4.4%, which is less than 5%. That means that's what I have just drawn this two distribution. One is the male distribution and then the female distribution. So male distribution is 11.663 and female is taking average 12.680. Okay, that means on an average male are closing the call in 11.6 minutes and female are closing the call in 12.8 minutes. So there is a mathematical difference, but is the difference statistically significant? That's what we are checking in this hypothesis testing. So that's what I said. Now look at this. Imagine these distributions are my palms right now. If and this middle finger, which I'm just indicating here, this is the average. All right. Now understand this. When both are exactly equal, let's say male is also 11.6, female average also 11.6, with the same distribution, they will overlap 100%. And in that case, p value will be 100% or 1. Are you clear? Just give me yes in the chat box. I'm just repeating again, once again. When it is exactly equal, p value will be 100%. Now let's make a small difference. Let's say male is 11.6, female is let's say 12. Female is 12. That's not a huge difference. Let's say the overlapping area is 50%. That means p value is 0.5. But what we say, if it is less than 0.05, which means 5%, right? Now let's make it even further. Now male is 11.6, female is almost let's say 13 or 12.8 in this case. Now it has gone even further away, the averages of both these distributions. The moment it crosses the 5% overlap, the statistics declares that there is a statistical significant difference between these two distributions or these two averages. Clear now? Okay, and this is called as two sample t-test. Okay, very good. Now let's do one thing. Let's go for the next level, which is called as paired t-test. I've just shared one file with you. When do we use this? Let's say you have a root cause like this vendor is, this vendor is better than the second vendor. First vendor is better than the second vendor. That's your assumption. That's your team says. So you say we will not take any opinion. We will collect the data and do the statistical checking. Hypothesis testing. Clear? When you want to compare two samples with each other, the averages, is there any statistical significant difference? Now, see what is happening here is, mathematically there is a difference, but statistical, what is the difference between mathematical and statistical? Mathematical is about the sample. Statistical is about the population, about the long term, about the future. So we are predicting the behavior. If this is a difference right now in the sample, is it statistically significant for the long term? That's what we are checking in this hypothesis testing p-value. Clear? Yes? So whenever you want to compare two things, two processes, two machines, two vendors, two processes, two people, two shift, then you can go for two sample t-test. Okay. Now there is another twist into this. Just open this paired t-test. Now what is paired t-test? Try to understand this. Paired t-test is when we want to check two samples which are coming from the same source. Example. When the sample is common, just try to understand this. I'll give you example of this. Let's say, have you opened a file? Paired t-test wala file have you opened? One is old analyzer and a new analyzer. Have you opened that file? Yeah, I'm just waiting for all the people to give me the confirmation. Yeah. So again, this will only open Ujjwalji when you have a laptop with Minitab software. I'm just sharing that in the chat right now. Can you see a chat file which says pairttest.mtw? Just click on that, it will get open. So you must have a laptop with Minitab installed. The same version, by the way, what we are using. Open, guys. All right, so let's understand this. Here, what is the difference between two sample t-test and paired t-test? Let's try to understand this, okay? See, I'm just sharing once again. Now you can see here. In the chat, you can check. Now, you can see here, there is an old analyzer data and a new analyzer. Just try to understand this. They have taken a same sample, a blood sample, let's say, and there is a pathology lab, and there is a blood analyzer machine. There is an old blood analyzer machine and a new blood analyzer machine. They are putting the specimen, the same specimen. So you can see here specimen number 1. It's a common sample, common patient. Specimen is actually being put in the old one as well as the new one. And we want to check whether any statistical significant difference between these two. When we have a common sample distributed against these two. Another example is you have taken your own weight at your gym and at your office or at your doctor. That is where two sample t-test. So sample is common. You are the sample, common sample tested against the weighing scale at the gym and the weighing scale at your doctor. That is called that is called pair t-test. Okay. Another one is, let's say Indian cricketer Yashasvi Jaiswal. How Yashasvi Jaiswal is performing under the captaincy of Rohit Sharma and under the captaincy of Virat Kohli. That is called pair t-test. Are you understanding this? Just give me yes in the chat box. Have you understood where it is used? So how do we do that? Go to stat, basic statistics and pair t-test. Click on that. Put sample 1 old analyzer, sample 2 new analyzer and click on OK. That's it. Just check the p-value. P-value says 0.003. So here the null hypothesis is X bar O, which is old analyzer, is equal to X bar new analyzer. This is my null hypothesis. My alternate hypothesis is X bar old analyzer is not equal to X bar new analyzer. Now P low null go, right? Now in this case, P value is 0.003. So in this case, what is your conclusion? What is your conclusion? P is equal to 0.003. So reject null, which means we have to reject null hypothesis and yes, very less overlapping, absolutely right. So that means there is a statistical significant difference between old analyzer and the new analyzer. Clear? Are you understanding this? So what we have seen is, if we have two samples, if we want to compare with each other, we go for two sample t-test. But if we have old the same sample tested against these two, then we can go for pair t-test. Okay, shows different reading. This means shows different reading, which means are showing different readings. So that's what. So there is a difference, and so there is a difference. Let's say, for example, the first reading says 189 in the first analyzer, in the old analyzer, and 201 in the new analyzer. So there is a difference. Okay. Now we want to check whether this statistically significant difference or not, and our p-value says yes, this difference is statistically significant. Okay. That's what it means. Now, when we want to, let's say you want to compare two samples with each other, we go for two sample t-test. What about we want to compare 3 samples or 4 samples or 5 samples? Then we go for something called ANOVA. Everybody just open this file called ANOVA, and let me quickly open this once again. Just open the file called ANOVA. Once you opened it, please let me know. Now, when do we use ANOVA? When we have more than 2, let's say 3, 4, 5, 6, 7, more than 2 samples averages to be compared, then we go for ANOVA. Just open the file. Once it is done, please let me know. Meanwhile, as you guys are opening the file, let me explain you the scenario of the data here. So there are 5 zones here, okay? Zone number 1, zone number 2, zone number 3, 4 and 5, okay? In every zone, there are 5 readings. So total 25 readings have been given. Yeah, what error are you, what error is coming, Ujjwalji, please, can you just let me know? First of all, do you have, have you opened the file now or not yet? Okay, now, now what you can do is, first you close all the other files. Just close all the other files, and once you close all the other files, then you download this one and just download, double click on that. That's it. It will open. Don't have to do anything else. Just double click on that. All right. Done. Yes. There is a ready reckoner which I am about to show you. Okay. If we want to compare more than 100 batches sample with 2 different instruments result, then compare more than 100 batches samples with 2 different instruments, then go for 2 sample t-tests. So that means you want to compare between 2 instruments, right? So go for 2 sample t-test, okay? If the same batch, understand this, if the common batch and you want to test it in 2 different instruments, then you go for pair t-test. One batch within 2 different instruments, go for pair t-test, okay? That's how it is. Very good. Now let's come to this. Now there are 5 samples here, 5 zones, and we want to go for ANOVA. So let's find out ANOVA. Go to stat ANOVA one way. Just follow this. Stat ANOVA one way. Stat ANOVA one way. Click on that. Here, response, in this case, response is the lead time, and the factor we want to test is the zone. What we want to check, whether the zone to zone, is there any statistically significant difference. So what this software will do, understand this. Okay, software will calculate the average x bar 1, x bar 2, x bar 3, x bar 4 and x bar 5. So the null hypothesis will say all are equal, and alternate will say at least one. Alternate will say at least one sample has a statistical significant difference from the others. That is called as alternate hypothesis. Okay, let's figure out that. Let's find out. Let's click on OK. So now we are comparing 5 means with each other. Let's click on OK. And there is a graph in front of us. Everybody got this graph? Can you read this graph for me? What is the inference of this graph? Yeah, what is the inference? What have you understood from this graph? This is zone 1, zone 2, zone 3. The center dot is the average, right? So for this one, this is 5.3. Then this is 5.4, very close to 4.5. Then again, this is 5.3, this is 5.28, and this is 5.29. What have you observed? if you see here, if you closely observe, if I draw histograms, it would look like this. Yes, everybody, can you see here? The same analogy which I used earlier for 2-sample t-test. Yes, similar kind of data distributions we can draw. Now you can see here this number 2, right? This number 2 distribution is a little in the danger zone, isn't it? The overlapping area seems to be very marginal. Can you see here? If I overlap all the 5, this one only is a little different. Yes or no? Can you see? Correct? If I overlap all the 5 of them, correct? Right? The overlapping area would be very good. Right? It's a very good overlapping area. But because of number 2 is a little farther, there is a little bit of what you can say on the edge. Let's check out our statistics, what it says. Okay. So just click on this sessions window. The sessions window meaning the short key is Control Alt M. Control Alt M. Just click on that, Control Alt M, and scroll up. Once you scroll up, you will see a P value here. Yes, P value, which is 0.018. Now it is less than 0.05. So we have to reject null hypothesis, which means there is a statistically significant difference. Yes, very clearly understood. Correct. Now let's do one thing, and we can easily understand which one is having the more difference. You can see all the means are captured here. Okay, the first one is 5.3, second is 5.44, third is 5.3, fourth is 5.26, and fifth is 5.28. So all of them are very close to 5.3. Only the second one is 5.44, which is a little ahead. So let's do one thing, go back to the data. Go back to the data. How do we go back to the data? Control Alt D, or this is the short key of this. Okay, remember these three. Always remember these three, what I can say, buttons, I would say. Okay, these 3 buttons. So this one is for the graphs. If you want to go for any graphs, just click on this. This one is for the data, and this one is for the statistics, which is the sessions folder. This one is the statistics. This window, which is right now in front of you, is called the statistics window, sessions window. Okay. So this is for statistics symbol, this is for the data symbol, this is for graphical symbol. Okay. So you can remember this. On the left hand side is stats, center is the data, on the right hand side is a graph. Clear, everybody? Now we want to go for the data once again. Let's do interesting stuff here. Let's click on the data and now remove this second number data itself. Just select that and delete that. Just click on delete. Now we have removed the second number wala data. Okay, let's do the same stuff again. Okay, how do we do that? Let's go to the shortcut, which is nothing but Control E. We will go for the edit last dialog box and just click on OK. That's it. Don't do anything else. Wow, look at this. You can see the change. The second number data has been removed. We have only 1, 3, 4, and 5. Now you go back to the stats and now you scroll it up and check the P value. Among themselves, they have 86.4% overlap. Very close to 100%. Yes, can you see? Just give me yes in the chat box. Everybody understood this? Just give me a quick yes. Meanwhile, very good. Done? Super. Yeah, meanwhile, there is a table which we are basically observing. It's called ANOVA table. Okay, ANOVA table. Now, I had actually conducted one complete session on this ANOVA table. Let me show you that quickly. Let me quickly show you that. Let me open that. I will give you the link of that session in that is there in the masterclass archive. Okay, let me just open that quickly for you. All right, now here we go. Let me just share my, everybody's aware of masterclass archive, right? So the p-value which is calculated by the ANOVA table. Okay, so this is the masterclass archive folder. On the left hand side, how you can search in that. Okay, left hand side there is a search option here. Just type ANOVA table. ANOVA table. You can see here decoding ANOVA table will come. I'm just opening that in front of you right now. So this is that basically the session which was conducted, and I would highly recommend, I'm just putting this in the chat right now. Please go ahead and check out this ANOVA table calculation. Okay, so this is the link I have given. It is there in our masterclass archive. Everybody got it? Yes. In this, I have decoded how this ANOVA table is calculated step by step. Each and every formula has been calculated there. Okay, I've given you. You can scroll it down, and you can just check out the statistical table. You can download. You can download the Excel file which can calculate it manually with formula. Okay, and the Minitap file. All the files have been given below this video. Clear, everybody? This is amazing resource for you. Just give me a quick yes in the chat box. Superb. Now, here is how do you remember all this different hypothesis testing. Okay, so understand this. In the green belt level, we have already covered the 1 sample t-test and a 2 sample t-test. Okay, so this is about if you want to compare two means, which is the averages. Okay, then this is the basically line we have to refer. 1 sample t-test, when you want to compare one sample with the standard, that is called 1 sample t-test. 2 sample t-test, which we have just seen, male CCO and female CCO. When you want to compare two processes, machines, vendors, okay, shifts, etc., then go for 2 sample t-test. Then comes the pair t-test. When do we use pair t-test? When the same common sample want to test against two different scenario. Okay, your weight in weighing scale of these two different locations. Pair t-test. Okay, old analyzer, new analyzer, same blood sample, both the machines. Pair t-test. If you want to compare more than 2, then you go for ANOVA. More than 2 samples averages, go for ANOVA. Clear, everybody? Is it clear for the mean? These are the 4 major types of hypothesis testing we do. Are you clear with this? Just give me a quick yes. Okay, clear? Now, see, when we draw a distribution like this, if you want to compare mean with the mean, X bar. So this is for that. Okay, clear? Yeah, what do you want me to repeat, Sandeep ji? Okay, let me complete this. Then if anything else is not understood, please let me know. Okay. Now, if the mean of this sample, if you want to compare another mean, okay, this is x bar 1 and x bar 2, then we will go for this line: 1 sample t-test, 2 sample t-test, pair t-test, and ANOVA. Clear? For mean. Now, what happens if you want to compare standard deviation, the distribution, the spread? Okay, so spread to spread comparison also can be done, and that's where this is very, very important. So if you want to compare two distributions spread with each other, we go for F ratio test. If you want to go for more than 2, we go for test of equal variance. Are you understanding? In the green belt, we cover mean, mode, median. This is for the central tendency, the center. And along with that, there is something called variance and standard deviation, and that is basically for the spread of the data. Whether the spread of one distribution is more than the spread of other distribution, that we want to compare, then it is called as this line, variability line. Okay, for the 2 samples, we go for F ratio test. For more than 2 samples, we go for test of equal variance. Okay. Now, if you want to compare the proportion, what is proportion? Let's say proportion defective. Shift 1, shift A and shift B. How much percentage rejection in shift 1 against how much percentage defective in shift 2? I will go for test of 2 proportion. If I want to compare 3 shifts or 4 shifts or 5 vendors, 6 vendors proportion, I will go for chi-square test. So the bottom line is, the bottommost line is the mean, comparison of the mean. Second is comparison of the variability, and the third is comparison of the proportion. And these are the various hypothesis testing you can do. Yeah, Sandeep ji, now you can ask me which one you want me to repeat. Clear? Can it be brought on the left hand side? No. Okay, fair enough. Clear, everybody? Just give me a confirmation yes in the chat box. See, when do we do comparison? Example. This is hypothesis testing, right? So we want to check whether my vendor A is faster than vendor B. Okay, so one of the root cause is my vendor always deliver the product late on time. That's what I got the delay. So I want to test this hypothesis. So I will collect the data. So what is the solution? Let's take the different vendor. Let's change the vendor. So we will collect the data from both the vendors and check whether is there any real statistically significant difference between these 2 vendor delivery time. Then we go for 2 sample t-test. We'll collect vendor A data, vendor B data, and we'll compare. If we have more than 2 vendors, we'll go for ANOVA. Clear? This way you have to basically. Now, let's say for example, both the vendors, there is no statistical significant difference. Okay. Now I want to check whether any variation is there. What is variation? One vendor, let's say, let me delete this. One vendor, both averaging the same. Let's say this vendor is also averaging 10 days. Second vendor is also averaging 10 days. The average is same, but this vendor standard deviation is 2 days. And this vendor standard deviation is 5 days. Are you understanding the difference between these two? Now I have taken the averages. Average is showing no statistical significant difference. Now I will go for variability. I will go for F ratio test. I will check the standard deviation to standard deviation. That is called F ratio test. If there are 3 vendors, let's say there is a third vendor as well like this, I will go for test of equal variance if it is more than 2 groups. Clear? This is how I will go for hypothesis testing with the real factual data, the real actual data rather than our opinions. Are you clear with this? Just give me yes in the chat box. So try to connect this concept with your own process. Okay, that will be more effective way of utilization. Okay, so let's quickly take some examples of this F ratio test and test of equal variance, etc. Okay, चलो, so मैं just ये सब हो चुका है, टी टेस्ट हो चुका है, एनोवा हो चुका है, या. So let's talk about F ratio test. So here, imagine So this example given, let's take few examples which are given in your curriculum only. So random samples of 12 and 16 are drawn from two population. The sample standard deviation are found to be 145 and 82. That means these are the two distributions. Okay, sorry. These are the two distributions. The standard deviation is 145 and standard deviation is 82. Okay. Here the number of sample size is 12 and here number of sample size is 16. Alright, now we want to compare, is there any statistical significant difference? So null hypothesis will say these are same and alternate will say these are different. Okay, so we want to check this, which is called as F ratio test. Okay, so let me just, yeah, you can open any, we just have to fill the data. Just open the same file which we have just used earlier. Just open the same file. Done? Yeah. Go to stat, basic statistics. Now we want to compare two variances here. Just come to this. Go to stat, basic statistics, two variances. Stat, basic statistics, two variances. Click on that. Now we will enter the data manually here. Okay. So here what we'll do, we will put sample standard deviation data, right? We have sample standard deviation data, correct? So just click on the sample standard deviation data. Everybody with me? I'll just repeat again. Go to stat, basic statistics, two variances, because we want to compare two variances here. Click on that. Here we will select sample standard deviation. So sample size number 1. So let me just read it out once again. So just you can just copy along with me. So the first sample is 12 sample size and standard deviation is 145. Second is 16 and standard deviation is 82. Alright. And we want to check whether there is any statistically significant difference between these two variances. Okay, just click on OK. Now this is what we have got. The p value is 0.043, which is less than 0.05, which means there is a statistical significant difference between these two variances. So obviously the variance of the first sample is high. See, variance always has to be less. Understand this. Are you understanding? Variance always has to be less. So whichever having the less variance, that is having the advantage. Okay. So the difference is statistically significant between these two samples. Clear? Everybody clear with this? Just give me yes in the chat box. इसका और एक practical example बताता हूँ. Okay. Which I always give this. Now, let's say Gautam Gambhir is Indian cricket team, the coach, and he wants to play, and he has got two options. Okay, one is Rishabh Pant and second is KL Rahul. Okay. Two wicket-keeper batsmen, but he has to select only one. So what he will do? He will take first the batting average. Okay. So batting average. Okay, let's say. Okay, let's not draw this. So first he will collect the batting average of Rishabh Pant. Let's say in T20 cricket. Okay, so that the batting average is 30, and KL Rahul batting average is 32. So he will check the p-value. Let's say p-value is not statistically significant. So 0. Let's say 0.08. Okay. So more than 0.05. So then Gautam Gambhir said, now let me, so this is what? This is X bar, correct? This is two sample t-test. Now Gautam Gambhir says, let's say, let me go for proportion test. Let me compare this standard deviation, the variation against each other. So Rishabh Pant's variation is 15 runs and KL Rahul's variation is 5 runs. So if I plot the data distribution, Rishabh Pant's will look like this. Average is 30 and this one, you know, the spread of the data is almost 15. And KL Rahul's mean will look like this. Average is 32, but the spread is very less. Very, you know, very centered and very lean. Are you understanding? And this is where the test of two variances will come into picture. So here there is almost equal. There is no statistical difference. There is a small difference, but it's not statistical difference. But here, if they check the difference, the p-value will be 0. Let's say 0.2, and that's where Gautam Gambhir decides, let's go for KL Rahul and you know, let's drop Rishabh Pant. Are you clear? The practical example. Yes. So in two sample t-test, there is no difference. Then let's go for the variance. Okay, clear? Just give me yes in the chat box. Yes, no, yes, no. Very good, very good. Okay. Now, when it comes to just a second. All right. Yeah, p-value is probability value actually. P-value is probability value. How you can see the area, overlapping area between these two samples. That you can say as a p-value. Yeah. Okay, now this is about a 2. Let's say same Gautam Gambhir wants to compare between Rishabh Pant, KL Rahul and Sanju Samson. Wow. Now we have the 3 samples, then we go for test of equal variances. Okay. So let's go for test of equal variances. I have just shared the sample file with you. Just open that quickly. Once you opened it, let me know. It is the same file which we have seen, similar file which we have seen in our this one. Okay, that ANOVA. Okay, the same file is there. Similar file, I would say. There are 5 zones basically, or 5 teams, and they want to compare the variances basically, or standard deviation. Right now, if you remember, when we used our ANOVA is when we want to compare the means, more than 2 means, right? Here we want to compare more than 2 variances or standard deviation. So I would say null hypothesis will say standard deviation of 1 is equal to standard deviation of 2 is equal to standard deviation of 3 is equal to standard deviation of 4, etc. And my alternate will say at least one has a statistically significant difference between these 2. Okay, these 3. So how do we do that? Go for stat. Opened everybody? Just give me a confirmation quickly. Yeah. So go to stat. There for the mean we have ANOVA, right? Here in the ANOVA itself, if you remember, we went for one-way ANOVA. So now here you go for test of equal variances. Okay, just click on this. Go to stat ANOVA test of equal variances. Just open that. In the responses, you select the lead time. In the factor, you select the team. Response, select the lead time, and the factor, you select the team and click on OK. Right, so here we can see the p-value is 0.386. Okay, which shows that the data is, there is no statistical significant difference between these two. You can see the data is very much overlapping with each other. Yeah. If I draw the distributions like this, there is very much overlapping and there is not a single what you can say variance which goes out. Okay. So the steps is go to stat ANOVA test of equal variances. Stat ANOVA test of equal variances. See, in your curriculum we have given the screenshots of it, so then just follow the screenshot, that's it. Sample files are also given in the curriculum, you can download those and follow the screenshot and just you can also do this. Okay, stat ANOVA test of equal variances. In the response is our lead time and the factor is our team, and click on OK. Done. Just give me confirmation yes in the chat box. Super, super. Now let's say, so we have, see like this. Can you see here? ANOVA, then go to stat, ANOVA test. So these kinds of screenshots also have been taken. Okay. And then the explanation, how do you write, what is the null hypothesis, what is the alternate hypothesis, very basically given. How do you interpret the p-value, interpretation of the p-value, everything is written. Okay. Now comes the proportion. So Leven's test is done when we have the non-normal distribution data. Okay, the distribution is a non-normal distribution, like we have seen the transformation wala thing. So when we have normal distribution, you don't have to go for Leven's test. Okay, if you have some kind of skewness in the data, then we go for Leven's test. Okay, yeah, let's go for proportion. Let's say 2 proportion test. Now again, proportion is, let's say, percentage defective, etc. Okay, that's a proportion. Out of 100, how many rejected? It's a proportion. If I want to compare 2, let's say shift 1 against shift 2, that is a 2 proportion, then we go for 2 proportion test. So let's see one example. A corporation purchase manager need to authorize purchase of 20 new photocopy machines. So Xerox machines की तरफ उनको करना है purchase. Alright, and after comparing many brands in terms of price, copy, quality, warranty, features, etc., they narrowed down the 2 choices, X and Y. Okay. So because corporation already uses both the brands, he was able to obtain information, random samples of 50 machines, because they is a big corporate. Okay. They already have 50 machines of each, and they have selected, the record indicate that 6 brand of X machine and 8 brand of Y machines need service. Now what does it mean? Let's try to decode this, which means, so what is the proportion here? So the proportion is this. they want to compare machine X and machine Y. So they have 50-50 machines. Out of 50, X machines are 6 machines are need some repair. So 44 machines are running good, and 8 machines of machine Y needs repair. So 42 machines of machine Y, they are running good. Now they want to compare whether this proportion, is there any statistical significant difference. So the null hypothesis will say they are equal, alternate hypothesis will say they are not equal. Are you clear? Have you understood this? Just give me a quick yes in the chat box. And now let's open this. Yeah. Let's open the same file which we have just done just now. Go to stat, basic statistics. To proportion. Just use this path, please. Go to stat, basic statistics to proportion. Now we will manually enter this, okay? Stat, basic statistics to proportion. So this window will come. So we'll select the summarized data. So we'll select the summarized data. So number of trials, 50-50. Both the trials are 50. And number of events, first is 44 and second is 42. Everybody just put this data. So 44 machines are running properly of brand X, and 42 machines are running properly for brand B out of 50. Click on OK. Now look at this P value here. This P value says 0.564. That means there is no statistical significant difference between these two comparisons. All right. So right now you can say both brands, as far as their qualitative performance is concerned, there is not statistical significant difference. So you can purchase any brand out of these two. That's what it means. Clear? Just give me yes in the chat box. Clear, everybody? Super clear? See, what happens is, Fisher का ये है ना, what is that? Okay, Minitab में थोड़ा time लग. See, there are a lot of statisticians who had their own way of calculation things. So Fisher also has got its own way of calculating this too. Okay. So what happens is they calculate on the basis of their own what you can say thing one. Like for example, the backend data basically. Okay. Backend data is generally taken differently. Okay. So there are different statisticians according to their own theory they are calculating. That's what I like this. Standard of, what is that? What is, I haven't understood this. What is standard of p-value? What is standard of p-value? मतलब मैं समझा नहीं. See, p-value is nothing but probability value. P-value is, see, that's what, there is no standard as such. What we check the p-value normally against 5%. 5% is nothing but 5 divided by 100. That is nothing but 0.05, right? That's why always remember the rhyming. P low, null go, right? Which means if the p value is lower than 0.05, reject null hypothesis. So remember this rhyming. So this is common, this is standard. Collect the data, feed that data, check the p-value. If it is less than 0.05, reject null. If it is greater than 0.05, accept null. That's it. Okay. Yeah, so that's how basically we generally suggest that keep it to 5% or 0.05. Okay. So generally that's what I said. So features, tests, etc. They use a little different formula to calculate, but both this says that there is no statistical significant difference. That's what we can make out of it. Okay. Clear? Now let's say if you want to compare more than two proportions. Okay. Let's say 3 shift. Okay. Let's say there are 3 shifts. And you want to compare shift 1, shift 2, shift 3, then we go for chi-square test. Okay, let me share with you a sample or a case of chi-square test, and then we will understand it. Okay, let's scenario this. Let's look at the scenario. They want to compare whether the shift has got shift to shift. Is there any difference between the customer complaints or the defects which are coming? Okay, so they have collected the data. Let's look at this. So this is a last test of hypothesis, which is called chi-square test. So let's try to understand this scenario. These guys have calculated there are 3 shifts, 1, 2 and 3. They want to check whether shift has got any significant difference between this, the rejections or defects. Okay. So there are different types of defects. They have A defect, B and C and D defects. Okay. So for example, for the first shift, A defect has come 15 times, B defect has come 21 times, C defect has come 40 to 45 times, D defect has come 13 times. Now, see, you don't have to understand how this chi-square test is basically calculated, but I will just explain it to you once. Okay, just understand it once. You don't have to do it manually. Okay, so it seems a little complicated calculation, but actually it is not. Just try to understand this. So have you understood how they have collected the data? Just give me yes in the chat box. Have you understood this? Now there are 3 shifts. That's what 3 comparisons we have to do, right? Proportion comparison. That's where we are going for chi-square test. Okay. Now let's calculate how the chi-square is calculated. Okay. Let's try to understand this. So just एक बार understand करते हैं, even you can forget it. You don't have to remember this. Okay. Now just try to understand this. So there is something called expected value we calculate for each and every stuff. What is expected value? Total, row total into column total divided by grand total. Now what is row total? This is a row, na? So 15 plus 21 plus 45 plus 13 becomes 94. This is called a row total. Clear? Into column total. So this is called column, right? So 15 plus 26 plus 33 is equal to 74. This is called column total. So row total multiplied by column total divided by grand total. What is grand total? All the row totals put together and all the column total put together. It should be equal value, which is called this grand total 309. Which means, for example, can you just pull out your calculator for one moment, please? And do this mathematics for me. Okay. What is row total? 94. Very simple mathematics. Into 74. A column total is 74. Sorry, 74, not 75. 74. 94 into 74 divided by 309. Now what we are calculating is the expected value for this value number 15. So we'll calculate it for every value like this. This is for the first value. 15 value ke liye expected value we are calculating. Can you just do this number? Calculate number and give me the number, please. 94 into 74 divided by 309. 22.51. Everybody got the same answer? So 22.51 is the expected value for this. Clear? Okay, let's do it once again. Let's do it for 26. So this one is the 26 value. Okay, can you just calculate? Row total is 96 into 74 divided by 309. Can you just calculate for this? 96 into 74 divided by 309. What is the expected value for 26? 22.99. Is it? Everybody got the same answer? So similarly, there is an actual value and there is an expected value they will calculate for every value. Clear? Have you understood how this is calculated? Row total into column total divided by grand total. Clear? Yes, again, I am repeating, you don't have to remember this, you don't have to do it manually calculate this, okay? Very good. Chalo. Now, let's do this. So this is like this. Like we have calculated 22.51, right? Expected value. So what they have done, they have calculated actual value and their respective expected values. Clear? Now what is the formula for chi-square? Chi-square is summation of actual, observe meaning the actual, minus expected raised to square divided by expected. Summation meaning you have to sum it up for all the values. Okay, like this. 15 was the actual value, minus 22.51 was the expected value, difference is square divided by expected value, which is 22.51. Then the next one, 26 minus 22.99, difference square divided by 22.99 and summation, and whatever value comes, which is 19.18, is called a chi-square value. Clear? This is how basically they calculate. Then what they do, they take this value, go to the chi-square distribution table, and from there they calculate the p-value. Okay, that's a back-end operation happens. Let's do one thing. I'm just sharing once, I'm sharing the file with you. Just open this file. We will do this with the help of Minitab software. Just open this file quickly. Once you opened it, please let me know in the chat. The same file has been given to you. All right, done. So the same data has been put here. Shift 1, 2, 3. A defect 15, B defect 21, the same data has been taken. Done? Yeah. Now just follow this path. So chi-square has a different path altogether. Go to stat, tables, cross tabulation and chi-square. Just follow this path. Stat, tables, cross tabulation and chi-square. This is a little different path than the other ones because most of them are in stat and basic statistics or stat and ANOVA. Okay, these are the two majorly used options, but this is the only option which goes in stat and tables. Okay, just click on this. This window will appear. Everybody with me? Just give me a quick yes in the chat box. Now here what you need to do is just select summarize data in two-way table because we are using this one. Okay, we are using this table right now. Okay, that's what we have to select, summarize table in summarize data in two-way table. Okay, so we'll select summarize data in two-way table. In this column containing, we will select A to D and click on select. So we'll select A, B, C, D. or we can select manually as well. Both are okay. Double click on A, double click on B, double click on C, double click on D. That is also okay. And in the rows, you have to, now this is a little tricky. Try to understand this. You have to select the shift and not shift number, because shift number is column number 1, which we are not considering for the analysis. We are considering column number 4, C4 column. Okay, so just select C4 shift. Everybody with me? Let me check. Yes? Okay, go to chi-square. Go to chi-square and just click on chi-square test and expected cell count. This is the same cell count which we have manually calculated just now. If you want to check, you can just check in, or you can just keep it aside. Just click on chi-square test. That is most important. And then click on OK and click on OK. Yes, everybody got this? Again, what we are looking for, this Pearson's chi-square value, which is 0.04, which is 0.004, not 0.04. It is 0.004, which is much lesser than 0.05. That means there is a statistical significant difference between the shifts. Okay, now you can see here. You can see here shift A, shift 1, 2, 3. You can see shift 1 is having 94, shift 2 is having 96, but shift 3 is having 119 defects overall. Are you understanding? Right? So what we are checking, the proportion between 309. So this is shift 1, shift 2 is 96 defect out of 309, and shift 3 is having 119 defects out of 309, and it shows the p-value is 0.004. That means there is a statistical significant difference. You can see here this shift, which is clearly evidence that there is a statistical significant difference because of the shift 3, and we have to focus on this shift 3. Clear? Just give me quick yes in the chat box. These are the proportion defects. Everybody with me? Super, super. Now let's, what we do, we'll just take a 5 minutes quick break, because we have another half an hour stuff pending, where we will cover around about the advanced regression topics. Okay, so let's do one thing. It's 8:27 right now. We will come back at 8:32 sharp. Okay, 5 minutes break, and then we'll talk about the regression, or any question you have about hypothesis, we will take out that. Okay, clear? Yes. Once you are back, just type I am back in the chat box, then we will start the session. Chalo, let's take the break. 5 minutes, huh? Yes, everybody's back on their seat. Please give me a confirmation yes so that we can start. Super. Yeah, I'm just waiting for all of the people confirmation. Very good, very good. Thank you very much for confirming. Let me just start it quickly. And now we are going to discuss about something which is, so hypothesis testing. Any doubt in hypothesis testing? Any question? Basic fundamentals we have already covered in the green belt level. This is where we, talk about the advanced levels. Okay, the fundamentals are absolutely same. Super. Chalo, let's discuss about the next one called regression. Okay, so regression we have already seen. Let me just share my yeah. So when do we use hypothesis testing? To check our assumption. See, in this Lean Six Sigma DMAC framework, what we believe is in data. In cause and effect and YY analysis, we use our experience. We find out the causes on the basis of our experience. We find out the root causes on the basis of our observation experiences. But that has to be basically proven with the data. And that proof with the data is called hypothesis testing. Hypothesis is nothing but assumption. Checking our assumption with the data is nothing but hypothesis testing. Clear? So it is a kind of validation. Similarly, there is another kind of validation which is called as regression. Just open this regression, this file, and we will first understand what is this regression and correlation. Example, let me give you example on this. Let me give you example on this. Let's say if I want to check the test of my tea is influenced by sugar. The test of the tea is influenced by sugar. So when there is no sugar, the test will be very low. When I add some sugar, the test will be a little better. When I add a little bit of sugar, so I will get a trend like this, and it's called as positive correlation. This is my X and this is my Y. Y is my output, X is my input. It is called positive correlation. All right. Now, there is something called negative correlation as well. What is negative correlation? Let's say, let's take water. Now, when I will put, let's say, when I will put, let's say more water, super more water. For just 1 cup of tea, I would add, more water. So my test will be, very poor in that case. Okay. And when I add, if I keep on adding more and more water, my taste will go down. Are you understanding? So the, what I can say, that this one will look like this kind of a trend I will get. I keep on adding the water, my test. Let's say when I have a perfect water combination, I will have the best test. But if I keep on adding water to my tea, my test will go down. This is called as negative correlation. and let's say there is humidity around, I want to check whether any difference my atmospheric humidity is making on my test of T. So I will see a pattern like this. It shows no correlation. Are you understanding? So positive relationship, negative relationship, no correlation. These are the three major relationships like this. Clear? Another example I can give is percentage marks and the just a second. Percentage marks and let's say your study. So let's say X is your let's say study time. Study time is your X. So more the study time, more percentage you will score. Okay. Negative will be your social media time or Instagram time. Okay. Yeah, Instagram time. So more time on Instagram, less score will be scored. And let's say your attendance of your college or your school and your marks. So there would be few students whose attendance would be less but marks would be very high. Few students attendance would be full but marks would be very poor. So attendance may not have a direct impact on the marks because the study, the actual value study what you are doing, that is what basically is all about. So it will be like this. Okay. So this is called a correlation. Let's find out what kind of correlation we have. So here what is there? We remember in the physics in our schools and colleges we used to basically used to hit the rod and measure the expansion of the rod, right? We used to measure the expansion of the rod. So we used to hit the what you can say, the metal plate. Okay. And first we used to measure the length, correct, with the help of vernier caliper. Correct. So the first we will measure the length with the help of vernier caliper. Then we will hit that, and then we will measure the length again. So this is the temperature and the expansion. So here X is temperature and your Y is expansion. Clear? Everybody's clear with this? Just give me yes in the chat box. And in our physics also we have done this. Even we used to do this, that there used to be a metal ball was there and there used to be a ring, correct? So we used to first, we could pass the ring in that ball very easily, and then we used to hit that metal ball, then metal ball would expand and it would not go in the ring. So that was kind of a physics exercises we used to do. So let's do this thing. So X is temperature, Y is extension. Let's go to stat, regression, fitted line plot. So select Y expansion, temperature, extension, X is temperature, Y is expansion, and linear. Select linear and click on OK. And you will find a line like this. Correct? So here everybody knows this. This is called as regression equation. This is all we have studied in our green belt level. Yes, just give me a confirmation yes in the chat box. The people who have not been through green belt, it would be a completely new for you. Okay. This is called as equation y is equal to a plus bx. In this, y is the output expansion, x is the input temperature. What is A? A is this, which is 7.5 1.449. Okay, so what is this? Just try to understand this. This is A is called as intercept. Make a note of this. Intercept. What is intercept? This is called line of best fit. This red line, right? If the red line I extend, it basically intersects this point, right? This is called 7.449. It is called intercept. And this is called as slope. B is called as slope. Slope. What is slope? Slope is nothing but how much difference. Let's say, for example, here I am increasing the temperature by 100 degrees. You can see here from 0 to 100, 100 to 200. So 1 unit for me is 100 degree. So with 1 unit change in X, how much difference it is making on my Y, which is the expansion, sorry. Okay, that means if I give 100 degree extra heat, that rod will increase by 0.02 mm or centimeter, whatever it is. And that is called slope. Clear? It is called Y is equal to A plus BX. Everybody with me? So we can use this equation and find out the value of Y very easily. This is also called as prediction equation. We can predict this. Okay. Tomorrow, when we will learn design of experimentation, we will see the prediction equation in the advanced level. Okay. And that will blow your mind completely. On the right hand side, we have got R square value. Okay. Now write down R square is nothing but the strength of the relationship of X and Y. Okay. Now if it is between 0 to 33%, it is low strength. If it is between 33 to 66%, it is moderate. And 66% and above, okay, above 66%, then it is called as, you can say 66 plus, it is called as strong correlation. So this is very close to moderate and strong correlation in between. And this entire analysis is called regression. So what we are checking is the temperature impacting my expansion? Is this, this value is checking my expansion? Okay. Yeah, I got S value as 1.0238. So S is standard deviation. S is standard. See, what is happening here is every time maybe software. Okay, have you selected this one? Have you selected the linear one? Just go back and check, have you selected the linear one or quadratic one? That is something interesting. Linear or quadratic? You check that. You might have selected quadratic or cubic. That might have reduced the S value. S is standard deviation value from that line of best fit and the actual dots. How much is the standard deviation from this? That is what they are calculating. So select linear. Yes, clear everybody with me? Just give me yes in the chat box. So we want to check. So this shows that there is a strong correlation between my temperature and my expansion. Clear? So this is very basic stuff which we have learned in our green belt level as well. Okay. Now let's talk about the advanced. Let's go back to the Control E. Press Control E. And instead of linear, just select quadratic. Just select quadratic and say OK. Now we have got something very interesting here. Now what has changed? Instead of line, because in the linear we have a straight line, in quadratic we have a curvature, a parabolic curvature here. And the equation is changing, R square is also changing because it is fitting the best. Correct? You can see here S, my standard deviation also has reduced. Earlier it was around 3, now it has got 2.02. Okay, now what is the equation here? this equation is different. Let me draw. So this line, quadratic one, is fitting even better. No? You can see it is fitting even better. Can you see? And the equation is like this: y is equal to a plus b1x plus b2x square. This is the equation we are getting here. So this is called as quadratic equation. And linear was y is equal to a plus bx, a simple linear equation. Alright? Again, you don't have to calculate it manually. We just have to check what is the best r square value. Okay, we will do linear, we will do quadratic, we will do cubic. Okay. Now let's do another one. Let's do cubic as well. Again, Control E. Now instead of quadratic, let's select cubic. Wow, this is even further. Yes, that's what the standard deviation is, 1.02. Krish, you got this same standard deviation, right? So it was a cubic standard deviation because this is the curvature exactly fitting to how much, the closest one. That's why the standard deviation from that line is very low. Correct? Now you can see r square value is 96.9. Very, very strong correlation it is showing. And the equation is, the cubic equation is y is equal to a plus bx plus, b1x plus b2x square plus b3x cube. Exactly. So because you had selected this cubic, okay, that's where this s value was this one. Okay. Now understand this. Here there are values. This a is intercept, meaning if I extend this values, this will bisect this somewhere here. That is this value called minus 0.6846. Okay. Then there is a positive slope here. Just try to understand this. Okay. Then there is a positive slope here. And this positive slope is 0.1169. And then you can see here, there is a slightly negative slope here. That's where this slope is a little negative, minus 0.000234. And again, there is a little positive slope here. Again, you can see a positive slope coming here. Are you understanding? So there are three slopes, 1, 2, and then 3. Which is basically getting here in this equation. Are you clear? This is how the equation is formed, and this is called a cubic equation. So whichever equation has the highest r square value, that is something which we have to select. And generally cubic will fit more in such kind of curvature scenario. Okay. Clear everybody? Quadratic and cubic. And Minitab is giving you all the three options. So you can check and test which is having highest r square value. That is our best model, best prediction model. Clear? So we can what you can say, project, or we can predict value of any x and any y with the help of this equation within the range of the data. Okay. Clear everybody? Just give me a quick yes in the chat box. So write down these three equations in your notepad just for your information. Y is equal to a plus bx. Write down linear. Y is equal to a plus b1x plus b2x square is quadratic. And y is equal to a plus b1x plus b2x square plus b3x cube is called as cubic. Okay. So you write down these three equations so that you can easily remember this. And again, just for your information. Okay. Clear? Now, what if we have multiple x's and one y? Now we have just seen one x and one y, right? Okay. What if we have multiple x's and one y? That's where matrix plot comes into picture. So let me just share with you something called matrix plot. Okay. Open this file of matrix plot, and meanwhile, as you are opening that, let me explain you this file. Open. It is called as stamping matrix plot. Just give me a confirmation yes in the chat box. Very good, very good. So you can see here, there is something called defect fraction. Yeah, because for me also there are a lot of files open. So for my system is also taking a lot of time here today. Yeah, sometimes it happens. So just close all the other files. It becomes a little faster. So what happens is there are, there is defect fraction, which is nothing but defect coming out of that process. There is a process, there are multiple factors, x1, x2, x3, x4 like that. We want to check what is the I think it is open. Let me just check if it is open in my system. Just a second. Oh, it's not. Yeah, it was not Zoom. Actually, it was not my Minitab. It was Zoom, which got a little hanged, I believe. Open. Yeah. I'm just waiting for my sheet to open. Just a second. Just give me a second. So in matrix plot, what happens is, if you want to check x1, x2, x3 and x4, how they are impacting your y in one shot, in one go, in one graph itself, and that is something called as matrix plot. Okay, so let me share as soon as it gets opened in my system. Okay, yeah, I'm just facing the same problem. Okay, let's do one thing. I don't know, it's my Minitab also as well as my Zoom also is giving me some trouble. So let's do one thing. We will cover this piece of matrix plot tomorrow, matrix plot as well as the multiple regression tomorrow. Okay, and along with that we will cover the design of experimentation as well, okay, which is very important topic you will love. All right, so let's do one thing, because there is some system error coming in. We'll close the topic today. It's already 9 o'clock, okay, and we'll connect again at 7 p.m. tomorrow, okay. So if you remember, yesterday we had a fantastic offer which a lot of people grabbed this opportunity with both hands. We have increased the master black belt price to 15,000 plus GST, okay. So if anybody wants to what you can say, upgrade for the master black belt, the price will be 15,000 plus GST for you guys, okay. Till yesterday it was 10,000 including GST. So a lot of people grab this opportunity, okay. So if anybody would still want to go for it, please message on the mentor's number, and we will think what can be done, because tomorrow also we'll have a final day, okay. So think about that. If you still want to upgrade, we can still extend that that offer. Otherwise from that day onwards, then it will be 15,000 plus GST, okay. Yeah, thank you very much. We'll connect again tomorrow. Till the time, keep learning, keep growing. Hope my system will be okay tomorrow, okay. Bye bye.